We'll start with the unsettling and work our way up to the most terrifying things in the universe. Intelligent alien life. The universe is roughly 13.8 billion years old and contains about 2 trillion galaxies, each holding hundreds of billions of stars. And most of those stars are now known to have planets orbiting them. When you run those numbers, the idea that Earth is the only place that ever developed intelligent life becomes statistically laughable. In the famous words of Neil deGrasse Tyson, to declare that Earth must be the only planet with life in the universe would be inexcusably big-headed of us. And that's exactly the terrifying part too, because if intelligent life exists out there, which it almost certainly does, why has the universe been completely silent? This exact question has a name, the Fermi paradox. The most unsettling answer people have come up with is called the dark forest theory, which is the idea that every intelligent civilization quickly realizes that announcing your existence is dangerous. So the rational move is to say nothing and stay completely hidden. Here's where humanity comes in. We have been broadcasting radio signals into space since the early 1900s, essentially waving our arms and advertising our location to anything that might be listening. We have no idea what might be listening, how advanced it is, or how close they are to blowing our planet to smithereens. Magnetars. A magnetar is a type of neutron star, and its magnetic field is so powerful that describing it in everyday terms almost stops making sense. Earth's magnetic field measures around 0.5 Gauss, and if you don't know what a Gauss is, it's basically a unit of measurement used to describe the strength of a magnetic field. A hospital MRI machine runs at roughly 15,000 Gauss. A magnetar operates at about a quadrillion Gauss. If one were placed halfway between Earth and the Moon, its magnetic field alone would strip the iron straight out of your red blood cells from that distance. You would be dead before you even processed what was happening. In 2004, a magnetar called SGR-1806-20 released a burst of energy in about 1/10 of a second that exceeded what our sun produces over 250,000 years. It was located 50,000 light years away, and it was still powerful enough to measurably disturb Earth's ionosphere from that distance. If one of these bad boys fired off within 10 light years of Earth, the radiation delivered to the surface would quite literally be catastrophic. Gamma-ray bursts. Gamma-ray bursts are the most energetic explosions in the known universe. In a matter of seconds, a single burst releases more energy than our sun will produce across its entire 10 billion year lifespan. They come in two types. Short bursts lasting under 2 seconds are produced by colliding neutron stars. Long bursts lasting up to several minutes come from the collapse of massive stars. A long gamma-ray burst aimed directly at Earth from within a few thousand light years would tear through the ozone layer almost instantly, leaving the surface fully exposed to radiation with nothing to stop it. Some scientists believe this exact scenario triggered the Ordovician mass extinction about 450 million years ago, wiping out roughly 85% of all life on Earth. What makes gamma-ray bursts uniquely unsettling is the complete absence of warning. They travel at the speed of light, which means you'd get marinated, cooked, and served on a platter before you even knew what was happening. There is no window between noticing one and being hit by it. Cosmic voids. Most people imagine the universe as a busy, crowded place, loaded with galaxies and star systems. The reality is that the overwhelming majority of it is empty. These empty regions are called cosmic voids, and they are enormous stretches of space containing almost no matter at all. The Bode's void, one of the largest known examples, spans roughly 330 million light years across. The entire Milky Way is about 100,000 light years wide, meaning you'd need more than 3,000 of our galaxy placed side by side to fill it. If you were somehow placed at the center of the Bode's void, the nearest galaxy would be so impossibly far away that the sky in every direction would be nearly pitch black. Astronomers describe the large-scale structure of the universe as looking like a cosmic web, with galaxies clustered along thin filaments of matter and voids filling the enormous spaces between them. Pretty spooky if you ask me. Neutron stars. When a star between 8 and 20 times the mass of our sun exhausts its fuel and explodes, the leftover core collapses into a neutron star. The result is an object roughly 12 miles across that still contains more mass than the sun. A single teaspoon of neutron star material weighs approximately 10 million tons, which is roughly the same weight as 5 million cars. Neutron stars also spin extraordinarily fast. The fastest on record, PSRJ 1748-2446 AD, rotates 716 times per second, with its surface moving at about 24% the speed of light. Many neutron stars emit tight beams of intense radiation as they spin, called pulsars, and from a safe distance, they're remarkable objects to study. From a close distance, though, you would most definitely get obliterated. They're small enough to fit inside a city, dense enough to crush anything that approaches, and spinning fast enough to win any Beyblade competition. Supernovas. A supernova is the explosive event that creates a neutron star to begin with, and somehow is even more frightening than the actual neutron star. The explosion can outshine an entire galaxy containing hundreds of billions of stars. The shockwave expanding outward travels at roughly 10% the speed of light, carrying intense radiation and high-energy particles capable of devastating anything in range. If a star within 50 light-years of Earth went supernova, the radiation would destroy the ozone layer, and the cosmic ray bombardment that followed would continue hammering the planet for thousands of years. The nearest serious candidate for a supernova is Betelgeuse, a massive red supergiant. At approximately 700 light-years away, it sits well outside the danger zone, but it's been behaving strangely. Between late 2019 and early 2020, it dimmed dramatically in what astronomers called the Great Dimming before partially recovering. Scientists estimate it could explode anytime within the next 100,000 years, which on astronomical timescales is essentially right around the corner. When it does go, it will be bright enough to see in daylight and cast shadows at night. The good part is that it will not affect Earth in any way, so no need to build a doomsday bunker just yet. Black holes. Black holes form when massive stars collapse under their own gravity, creating a region where the escape velocity exceeds the speed of light. The boundary marking the point of no return is called the event horizon, and crossing it is one way regardless of what you're made of or how fast you're moving. At the center lies a singularity, a point of infinite density where general relativity and quantum mechanics both break down simultaneously. If you somehow found yourself in a situation where you were falling into a black hole, you would cross the event horizon without any dramatic sensation in that moment. But what followed would be a process called spaghettification, where tidal forces would stretch you lengthwise into a stream of particles before you ever reach the center. The supermassive black hole at the center of our galaxy, Sagittarius A, contains the mass of roughly 4 million suns and sits about 26,000 light-years from Earth. It's not just our galaxy, though. Nearly every large galaxy we've observed has a supermassive black hole at its center, which is pretty frightening. The end of the universe. The most widely accepted model for how the universe ends is called heat death, also known as the Big Freeze. The universe is currently expanding and will continue to do so. Over time, galaxies drift apart, stars exhaust their fuel and go dark, and everything gradually approaches a state of complete equilibrium where no energy can flow and nothing can happen. After roughly 10 to the power of 40 years, the protons making up all ordinary matter may decay entirely, erasing every atom that has ever existed. After around 10 to the power of 67 years, the black holes around the universe will begin evaporating through Hawking radiation, and will slowly lose mass until they disappear completely. What remains after that is a universe that is infinitely large, cold, completely dark, and incapable of producing any event, structure, or change. By this point, the universe will have achieved UNC status, and will no longer be considered cool anymore. If you like this video, subscribe for similar ones. Thanks for watching.